Hi, hello, welcome to your home school. This is your fifth session in our probability. Last class we have completed up to card problems, that is 15 problems we have done. So we are going to start in this session from the 16th problem. So let me read the 16th problem in your textbook. If you have your textbooks, you can see the problem from your text. So 12 defective pens are accidentally mixed with 132 good ones. It is not possible to just look at a pen and tell whether it is a defective or not a defective. One pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. So what is the question they are asking here? They are given us 12 defective pens and 132 good pens in a lot. Suppose if you are going to pick that pen from a lot, we can't say whether it is a good or a defective. How can we say it is a good or defective? Until we write on a book, we can say it is a good or defective. So, is going to pick a pen from the lot. What is the probability? Our question is, what is the probability that the pen taken out is a good one? Okay, before starting a problem, what is the first step we are going to write? Total number of sample spaces. How many pens comes under sample space? So n of s. N of s is none other than defective pens 12 plus good pens 132. That will be 144. In this lot you have 144 pens. Our probability event question is, what is the probability of getting good pens? Good pens, if you want, you can consider P of G. Probability of getting good pens is equal to N of good pens by total number of possible outcomes. N of good pens. Okay, we can consider this one good pens now. So we can assume here N of G here itself. That is 132 by 142. See how simple it is, very easy. Problem, if we understand problem, is very easy. The same thing we can change the question. What is the probability of getting here defective pens? Defective pens means P of D. P of D is equal to N of D by N of S, that is 12 by 144. Very simple problems. So 17th problem. A lot of 20 bulbs. Okay, in this before problem we have seen the pens. Now in this we are going to say about the bulbs. A lot of 20 bulbs contain 4 defective ones. One bulb is drawn at random from the lot. How many good bulbs and how many defective bulbs are there here? There are 4 defective bulbs, a lot of 20 bulbs. So, defective 4, how many good? We can just say it as in total number. If you remove, you are going to get your count. Total number of good bulbs, how many good bulbs are there here? 16. So, let's read the question. One bulb is drawn at random from the lot. What is the probability that this bulb is defective? What is the probability that this bulb is defective? How many defective bulbs are there here? Total first we are going to write N of S is equal to 20 bulbs and defective bulbs N of D is equal to 4 and probability of getting a defective bulb is equal to N of D by N of S. This in your notes, if you want, you can write sentence wise total number of sample spaces, total number of defective bulbs can be written as N of D is equal to 4. In this way we can do. Coming to your second sub question. Suppose the bulb drawn in first is not defective and is not replaced. Okay, not defective. Understand the question here carefully. I am picking a bulb which is not defective. Not defective means good bulb. So one bulb, let's pick it here and imagine this is your bulb. Okay. So from this one bulb is kept aside. So total how many bulbs you have now? 15 bulbs. So total how many bulbs here? Good bulbs. good bulb is equal to 15 bulbs. In our question, they already 16 there, right? 16, one bulb is removed, so it will be 15. So our question, see carefully. Suppose the bulb drawn in the first main is not defective, good one, and is not replaced, means we cannot consider in our second sub question. Now one bulb is drawn at random from the rest of the bulbs. What is the probability that this bulb is not defective? See here carefully. Sample spaces also it will be changed. Sample spaces in total 20 bulbs. In good bulb, one bulb is removed here. So here how many we have? 15. How many defective bulbs are there here? 4. 15 plus 4 will be 19. N of S is equal to 19. And your question here, what is the probability that the bulb is not defective? Not defective, we know it is a good bulb. So probability of getting good bulb is equal to number of good bulbs by total number of sample spaces. That is 15 by 19. Understand the question here. Most of the children will do wrong writing 16 by 19. There they gave a word, one bulb is taken out and not replaced in the lot. Is this clear? What is your next 18 problem? A box contains 90 discs. I have drawn only 5 discs. Imagine these as the discs. And it is a box. A box contains 90 discs which number from 1 to 90. If one disc is drawn at random, okay, I am taking one disc from the box. Find the probability that it bears a 2-digit number, a perfect square number, a number divisible by 5. There are 3 sub-questions in this. We are going to start the first sub-question. Before starting first sub-question, what is our rule? In our probability, first we start with the total number of sample spaces. There are 90 discs in the box. That means total sample spaces N of S is equal to 90. First question. A two-digit number. You all know what are all the 2-digit numbers. How many 2-digit numbers will be there in this box? So let's take any event letter. Let me consider, let the event be E1. Let's start with the flower bracket. What are all the 2-digit numbers you know here? 2-digit numbers start from 10, 11, 12, so on. How many 2-digit numbers we have here? 90. So on. Instead of writing all, we can end it like this. So can we count this? No need of counting 10, 11, 12 like this. No need. Out of 90 discs, I am not assuming 9 discs. I am removing 9 discs and other discs are all considered. So total how many we have here? If you remove 9 in 90, what you are going to get? 81. N of this event is equal to 81. And what is the probability of getting this 2-digit number? Formula P of E1 is equal to N of E1 by N of S. That will be 81 by 90. That's all very simple. Coming to your second question. A perfect square number. We know, everybody know about the perfect squares. What are all the perfect squares? We must have read the perfect square table. 1 1s are 1, 2 2s are 4, 3 3s are 9. Like this. Let's start writing. Perfect squares. Let the event be E2. E2 is equal to 1, next 4, 9, 16, 25, 36, 49, 64. Okay, let's shift this problem this side. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 perfect squares in this event. N of E2 is equal to 9. Probability of getting this event is equal to N of E2 by N of S. 9 by 90. That's it. That is your answer. Third one. Third sub question here. A number divisible by 5. See in this box, what are all the numbers which are divisible by 5? From 1 to 90. You should remember the range. What you have? 1 to 90. What are all the numbers which are divisible by 5? Let the event be increased. Start with the set 5, 10, 15, 20, 25, 30, so on up to 90. So if you want, you can count with the fingers. Let's start counting here. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. So total how many we have here? 18. So N of E3 is equal to 18. Probability of getting this event P of E3 is equal to N of E3 by N of S is equal to 18 by 90. I hope this is very clear. It's very easy problem. Next, 19th problem. A child has a die whose 6 faces shows the letter as given below. Normal die, we know that it will be having 6 faces. 1, 2, 3, 4, 5, 6 will be having. But here 6 faces they have given. A is repeated. Can you observe? A, B, C, D, E, A. So what are all the sample spaces? Number of sample spaces is equal to 6. Yeah, question here. A die is thrown once. If it is rolled, what is the probability of getting A? Probability of getting A. How many places you can see here? A, 1, 2. So, occurring this event N of E1 is equal to A, comma A. That is equal to E1 is equal to A, comma A. N of number of this is equal to 2. Same manner, P of E1 is equal to N of E1 by N of S. That will be 2 by 6. You can rewrite this as 1 by 3. And second one, what is the probability of getting D? Probability of getting D. D where you have at only one side. So same manner you can write it as N of E2 is equal to 1. P of E2 is equal to N of E2 by N of S. That will be 1 by 6. So 20th problem. 20th problem. You can see a rectangle here and a circle. Same manner. Look over here. Suppose you drop a die at random on the rectangular region shown in the figure. What is the probability that it will land inside the circle with a diameter 1 meter? This is one different problem in your probability. So you can see here a rectangle. I have drawn a rectangle. Inside there is a circle. A die is thrown in the circle. What is your question? A die is rolled and it is thrown inside the circle. What is the probability? You all know sample spaces, all the possible outcomes. Now what are the sample spaces here? This complete area of a rectangle is your sample space. What is area of a rectangle? Everybody know what is area of a rectangle? Length into breadth. So here let's start our sample space. Yes, N of yes is equal to 3 into 2. That will be 6 meters. This is your sample space. What is the probability? Probability question. What is the probability that it will land inside the circle of diameter 1 meter? Diameter 1 meter. What will be the radius? Half of the diameter is radius. That will be r is equal to 1 by 2. Area of a circle. Area of a circle. What is area of a circle? Pi r square. Area of a circle is pi r square. This is n of even. Our even question is this, no? Instead of area of circles, I write it as n of even. Pi r value will be 1 by 2 whole square. Pi by 4. Pi by 4. What is the probability of occurring this event? P of even is equal to n of even by n of s. That will be n of even. N of even you have here pi by 4. What is your n of s? 6. Here whole divided by 6. If you are going to bring this to the numerator into 1 by 6, that will be pi by 24. Probability of getting this event is pi by 24. The next question is 21st. Yeah, 22nd problem. Refer to example 13. Complete the following table. Already our table is ready on board. Let's have a look here. Event, sum on 2 dice. What is our event here? Event question is summing on 2 dice what we get the answer. So, if the possibility is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are all the event questions you have. You are going to calculate what is the probability of occurring this event. Probability of occurring when 2 dice are thrown. Probability of getting 2 is 1 by 36. 3 answers already solved here. Let's solve the remaining part. First, what is the first thing we do here? Always if any question is asked, we are going to write the sample spaces. How do we write here? If a question, don't be confused. There are 2 chances of asking the same question. If a die is rolled twice or 2 dice are rolled, both the answer will be same. Both you are going to get the sample spaces will be similar. Sample spaces is represented by S. S is equal to. If 2 dice are rolled, 1 die your option is 1, 2, 3, 4, 5, 6. And another die your option is 1, 2, 3, 4, 5, 6. When you mix and then what you are going to get here? 1, 1, 1, 2, 1, 3, 1, 4. What are all the possible outcomes we are writing here? 1, 5, 1, 6. 2, 1, 2, 2, 2, 3. Yeah, you can see this all up to 6, 6. Total how many possible outcomes you have here? 36. Therefore, number of sample spaces is equal to 36. This is your question table and your sample spaces. Let's start dealing one by one here. Event. What is our event? Sum on 2 dice. Of course, getting 2. Getting 2. Sum here. Can you observe here? Sum. Sum means what I have to do for this sample spaces. We are going to write another set here by adding. By looking, I can't say what is the sum directly. So for that purpose, I have added. Look over here. 1 plus 1, 2. 1 plus 2, 3, 4, 5, 6, 7. So similarly, I have added full sample spaces. Can you have a look of this one? So this is your present sample space to do this problem. First one. What is the event of getting 2 when 2 dice are thrown? Can you see only at one place we can see 2. What is your chance of happening that event? So, let E1 or you can say just 2 n of E1 first you can write it as E1 chance of getting 2. E1 is equal to only at one place we got n of E1 is equal to 1. Probability of occurring this event is equal to P of E1 is equal to n of E1 by n of S. That will be 1 by, how many you have here? 36. 1 by 36. Same thing. What's your second sub question? Probability of getting 3. let it be E2. E2 is equal to 3. How many places you got here? 1, 2. I'll write it here. You may write it as 1, comma 1. Here, what is this 3? What is this 3 value here? 1, comma 2 and 2, comma 1. N of E2 is equal to 2. P of E2 is equal to 2 by 36. So, similarly, we are going to solve all the problems. So, what you are going to do? First problem, second problem is very easy. Third problem also easy. Fourth, look over here. 1, 2, 3. Where is this 4 in this set? Have a look. 1, comma 3, 2, comma 2, 3, comma 1. You take one more event here. E3. E3 is equal to 1, comma 3, 2, comma 2, 3, comma 1. You write, count the events. N of E3 is equal to 3. P of E3 is equal to 3 by 6. In this pattern, you can complete this problem. Just let's do orally by seeing this. See, now 3, what is your answer here? 2 by 36. Coming to your 4, 1, 2, 3. So, what is your probability? 3 by 36. Next chance is 5. 5, look over here. 1, 2, 3, 4. 4 by 36. Coming to 6. 1, 2, 3, 4, 5. That will be 5 by 36. Coming to 7. 1, 2, 3, 4, 5, 6. 6 by 36. 8 answer already given, but let's check it out. 1, 2, 3, 4, 5. 5 by 36. 9. 1, 2, 3, 4. 4 by 36. 10. 1, 2, 3. 3 by 36. 11. 1, 2. 2 by 36. And at 12, it is only at one place. That will be 1 by 36. See here, the method in your exams, you are going to write in this method. So, I have done you 2 and you have to complete the remaining part at home. Complete this problem. This is very, very easy. Not only this, one more chance of asking the question, what is the multiple of these 2 dice? 1 ones are 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, 10, 12, like this you are going to write. And then your event questions will be, what is the probability of divisible by 2, divisible by 3, divisible by 4, they may ask. Any problem, the technique is same. I think it is followed, children. So let's move to the next problem. In this again, one more sub question there. Just a tiny question they asked. What is that tiny question? A student argues that there are 11 possible outcomes. What are the possible outcomes here? 2, 3, 4. See, look over here. These it seems. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Therefore, each of them has a probability of getting 1 by 11. Just have a look. Each will be having a probability 1 by 11. 2, okay. 2, 1 by 11 you can say. 3, 2 times it is repeated. 2 by 11. 4, is it correct? No, I cannot agree with this question. So, what you are going to write here? Therefore, I cannot agree with the given argument. So, each outcome is not equally likely. Every chance is not equal. Therefore, it is not equally likely. With this, I am going to end this problem. And then, 23rd problem. A game consists of tossing a 1 rupee coin 3 times. Same question, one more way I am saying here. If 3 coins are tossed at a time or 1 coin is tossed 3 times, both the question will be having same sample spaces. Please don't confuse here. And noting its outcome, each time Hanif wins if all the tosses give the same result. 3 heads or 3 tails. And loses otherwise. Calculate the probability that Hanif will lose the game. What's your question here? We are dealing with the coin. When the coin is tossed 3 times, Coin is tossed 3 times. Actually, if a single coin is tossed, very easy. What are the outcomes? Heads or tails. If 2 coins are tossed at a time, I may say here, have a look. H, T. Chance of first coin, second coin. Head, tail. How do you say all the sample spaces? Head, head, tail. Or tail, head, tail, tail. How many sample spaces here? 4 sample spaces. Whereas coming to 3, little difficult you may get. So I am going to say you easy technique how to write the sample spaces here. A rough sample space here, that is head, tail. No need of brackets also. Head, tail, head, tail, tail. Okay, this is only for 2 coins. In our question, 3 coins. Hint, you never do wrong if you remember this technique, but don't do this line in your exam. So, with H, first I make the H arrangement beside every set. Then again, T arrangement I am going to do. Let's write here. S is equal to, have a look, H, T, H. I am giving a little space for those letters. T, H, T, H. Next, head completed. We are going to take the tail. Again, give this arrangement. Who has to sit here? Tail. H, T, 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 H, T. T. That's all. 1, 2, 3, 4, 5, 6, 7, 8. So, how many sample spaces are there if 3 coins are tossed or a coin is tossed 3 times? How many sample spaces we have here? 8. N of S is equal to 8. Who is the person here? Hanif. He wins the game. When he get all the time same answer. When he toss the coin, first time he may get head, second time also head, third time also head. If we get this option and same chance set, one more we have same chance set. What is that? Tail, tail, tail. So if Hanif is going to get these 2 answers, he is going to win. If he won't get these 2 answers, he is going to lose. What is your probability question here? Calculate the probability that the Hanif will lose the game. Let the event be E. Winning only these 2, no? Losing. Right here. H, T, H, T, H, T, T, H, T, 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 T. Okay. How many you have here? N of E is equal to 6. Probability of occurring this event is equal to 6 by 8. Therefore, the Hanif is losing a game. What is the chance here? 6 by 8. This is your answer. 24th question similar to this question. So, let's read what is your 24th question. A die is thrown twice. Same manner. Look over here. A die is thrown twice. What is the probability that 5 will not come up either time? 5 will come up at least once. So, let's see the problem here. Okay, here itself I am going to continue the problem. Okay, what's the number here? 24th problem. Throwing 2 dice. So, your sample space is already ready there. Here 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. So on up to 6, 6. What's your first question here? Same manner, N of S is equal to 36. First question. 5 will not come up either time. Will not come up either time. This you can do 2-3 methods you can do. 5 never comes any time. So here, how many times it comes? Let's check out first. Where is that? Here, one time, 1 5, 2 5, 3 5, 4 5, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, 6 5. See how many times it comes up. Let's see first. Then we can answer not coming up. So here, any time it does not occur is your question. So I need probability n of e bar. I want my question. Okay. First, let's go with n of events. Event, it is a not e question. First, let me do how many times it comes up. Let's check out. How many times it is coming? 1, 5, 2, 5, 3, 5, 4, 5, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6 and 6, 5. So how many times it is coming? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here n of e is equal to 11. See here I am writing n. Don't think it is as a p. P of e bar. Immediately you can say p of e bar plus p of e is equal to 1. But I am not writing probability. I am just writing the number of events in the sample spaces itself. So here, how do you get now n of e bar? You can write it as total sample spaces, total all possible sample spaces. In that you can remove 11. What will be your answer here? 25. What is the answer we need for this question? That is 25. Now you can write it here. Probability of not occurring this event is equal to probability of not occurring any either time 5 is not coming up, that is n of e bar by n of s. Total number of sample spaces are 36 and this question answer is 25 by 36. Let's go with the second sub question. It's very easy. Already we have done that. What is your second question here? 5 will come up at least once. At least, at most words, you should be careful here. At least once. At least give me a pen. No, I have 2 pens. Or at least give me a chocolate, you may ask. Your friend is so friendly, he may give you 2 or 3 chocolates. Means at least word 2 or more than 2. But coming to your at most word, at most 2 rupees. At most means 2, 1, 0 will be included. At least 2 means not below 2, more than 2 you have to see. But here at least 1 is your question. At least 1 and above you have to choose. So at least 1 time 5 should be repeated. 5, 2, 5, 3, 5, 4, 5, 5, 1, 5, 2, 5, 3, 5, 4. At least 1 then here 2 times it is repeated. 5, 5, 5, 6, 6, 5. So same set you may write it here. Directly I am writing here. This is only E. Directly I am writing here. N of occurring this event is equal to 11. Probability of getting at least once 5 is N of E by N of S. That is 11 by 36. Last and final one more question we have. Just let's answer here. Which of the following arguments are correct? Which are not correct? Give reason for your answer. Correct or not correct? True or false type question. If 2 coins are tossed simultaneously, there are 3 possible outcomes. Oh my God, 2 coins are tossed. Do you feel 3 possible outcomes? We have seen just now. Look over here. If 2 coins are tossed, how many outcomes you are getting? 1, 2, 3, 4. But in your question, 3 possible outcomes. 2 heads, 2 tails or 1 of each. Is it right? No, it's not correct. Your probability for each of these outcomes is 1 by 3 itself. Look over here. Probability of getting both heads 1 by 4. Both tails 1 by 4. Each of them will be 2 by 4, that is 1 by 2, not 1 by 3. Second sub question here. If a die is thrown, there are two possible outcomes. An odd number or even number. If a die is thrown, immediately remember 1, 2, 3, 4, 5, 6. So in this, 2, 4, 6 are even, 1, 3, 5 are odd. Look over here, they are not saying only two answers, they are not saying. Two options of answers. What are the two options? Either if a die is rolled, either it may be even numbers or odd numbers. Yes, it is correct. Still, let's see here. Therefore, the probability of getting an odd number, okay, now chance goes to odd number. Odd numbers, how many we have? 3. Total number of sample spaces? 6. If you cancel, what you are going to get? 1 by 2. What is the question here? Probability of getting an odd number is 1 by 2. Yes, I agree with this answer. With this, we are going to end a very tiny chapter, probability. Thank you everyone for watching. Please subscribe.